this is the entire system of a prototype, and this is the power bank which will be used to power the entire system. And this is the depth camera, which is a stereo camera, Intel RealSense D435 stereo camera, which is used to capture the surrounding depth information. And this is directly processed using the Raspberry Pi 5, and these are connected to 8 BRV8833 motor drivers, and it is used to run the 15 haptic vibrating motors. And as you can see, these are the 3D prints which will be clipped onto the belt of the final product. And in the next coming stages, we will be replacing these motor drivers with a much more compact transistor system. And we're currently in the design phase, and we're going to give the designs for PCB printing tomorrow. And also, as you can see, this is not a finished product, and in the coming days we will be converting this glove into a much more aesthetically pleasing and much more finished, refined prototype system. And each of these components will be fitted directly onto the belt, and I'll show you how the final system of the prototype would look like in a minute. So as you can see, the image we capture on the left is the depth image, the raw depth image that we captured, and the image in the right is the processed 3x5 resolution 15 pixel image. Each of these pixel blocks are directly mapped to each of the 15 haptic vibrating motors on the glove. And as you can see, as we change as a person comes closer to the object, we can see how the camera detects it, and everywhere where there is obstruction, the camera turns black, indicating that the obstacle is most closer, and when the obstacle is very far away, it's represented using white color. Now I've connected all the motors to the power supply, and as you can hear from the motors vibrating, as I come closer, the pixels start turning gray, and the corresponding motor starts vibrating. And as I get very close, the entire segment of that motor gets vibrated. And as I move far away from the field of view, the pixels turn gray, then white, and the motors stop vibrating. Motors vibrate at 100% intensity when the object is very close to the person, and vibrates at 20% intensity only when it is slightly far away from the user, and it does not vibrate at all when the obstacle is very far away. Okay, so as you can see, this is how the final prototype would look like. This is where the power bank would be, and this is the Intel RealSense camera, and this is where the Raspberry Pi would be. And as you can see, the blind person or the visually impaired person can move around freely, hassle-free, without any issues and without any interruptions, and navigate easily through the surrounding. And this is an abstracted view of as to how the glove might look like in the end. And these would be some of the wires that will be attached to the glove. And in the future coming years, we can easily make this entirely wireless, and maybe make this entire system compact into a single unit, and make it even more convenient and portable. Thank you.